Well, it actually sounds like the most fun role in the room today is the expert panel. So feel free to do some grilling. That's always interesting. So, hi, I'm Grant. It's very nice, honored to be here today. Very nice to have the opportunity to talk about geologic AI, but more importantly, it's the deep demands that the mining industry has for innovation, and the support we need to give the people in the room and the presenters today on just how hard industrial adoption is. And what we need to do as an industry and companies is elevate. So I truly thank the sponsors, and you think about like, how can we as an industry elevate because there's big crisis coming in mining. And it's a very slow car wreck to watch. And so whenever we see a room full of people like this who are at the fringes and trying to elevate, you just need to take a moment and acknowledge how difficult this is and how difficult industrial innovation is and what that takes: community support, boots on the ground, all the things that have to happen. And it's very near and dear to my heart to talk about that. So we've gotten, as GeologicAI, we're very fortunate to have gotten over that trough of despair, or hump of despair, whatever you want to call it. But it takes a long time, right? And the strategy for doing so is an interesting one. It's how do you pick a narrow enough vertical or a good enough proof point that you can expand from, you can have success, you can have failure, you can do it publicly, to really start to drive important change. And for us, I mean, having done this since 2013, you kind of, the wave of critical metals kind of hit us at a nice timing too. So there's a lot of kind of luck involved in getting this going. But I'll talk a little on GeoAI, a little on the industry. I present a lot about the crisis that's unfolding in front of us. And so I'll talk to that first, talk about value of innovation, and then just show kind of how we think about it and how important the business and risk aspects are and how to get it funded and how to do that. That's kind of my superpower. So I'd like to introduce GeologicAI. We have a term, high resolution decision engineering, that encompasses our technology stack. And of course, high resolution meaning we can now deal with information and rocks as they are at the resolutions that the deposit is actually in. And then we can have engines and big compute that can completely optimize capital flows. Sorry, I've got a flashing screen here. So why, what, and how? So we need to double down on innovation. I'm just going to do a quick talk on where the critical metals juncture is, just to set the table for how important the problem is. And then, of course, what does GeologicAI do, and how do we make it real at every level? So there is nearly infinite demand for critical minerals at this projecting point on how people are building data centers. You can look at the US economic growth, the wedge, $400 billion. The entire growth of the US wedge is the same size as the data center commitments and spend that is happening right now with the Magnificent Seven. And it's infinite because we can't project when the costs will reconcile on this. We have investor exuberance happening today. It happened in the 90s with the internet. Yes, the internet was foundational changing. Yes, they got overly exuberant, and there was a flat period through the 2000s, right? People don't remember that, but we'll see this in AI. There's right now nearly infinite demand. You can't buy a GE turbine to run natural gas power generation until 2030 now. And so that's just a crisis. Talking to TEPCO, Japan's operator of their grids, this is the first time they've seen demand growth in Japan's electric grid. And they have to grow the entire thing, they're projecting, by 40% in the next 10 years. So that's 40 gigawatts, I think it is, on an 80 gigawatt grid, so almost 50%. And that's TEPCO. And so can we use AI, can we use the thing that's causing the crisis, this AI, to actually optimize and accelerate critical metal supply? So that's, can we use this, the crisis causing thing, can it be used to help that? So can we turn this vicious cycle of we want to electrify, we want AI, we want all this to happen, we need way more energy than we've ever needed in the past, and yet we still want the environment, We still care. What do? Can we use AI to actually optimize this all the way through? So, simple, copper demand. All reasonable projections. AI looks like 1 million metric tons. So, consumption in North American data centers is the other piece to that. Supply is not keeping pace. Copper is an absolutely critical metal. I don't use it because there are other critical metals, obviously, but copper is just the bellwether because of its volumes, right? It's a very large-scale market. And the supply gap is obvious. So any reasonable forecast shows that pretty significant gap in supply. And I liken this to the oil industry because I started there in 2000. You know, oil was $9 a barrel in 2000. You may not remember that. I started my career as one of the only people employed in reservoir engineering at the time. The next year it was 12. The next year it was 25. And we sat there at $25 oil and went, well, that's got to go back down. You know, that's just the nature of it. Everyone thinks that way. Copper, $3, $4, $5. Yeah, that's got to go back down. Does it? Or is there an actual real gap? It takes 17 years to go from a resource to a mine on average in copper. It takes 8 to build the electrical wires. So really what we have to do is convert resources that are getting more difficult into mines faster. And how are we financing it? The casino that is the TSXV, right? It's almost embarrassing what we're doing to finance. And so when you look at these problems and how we're not financing the resources, how there's deep demand here, and we've got all these new tools, we can analyze thousands of things at once. We can optimize capital flows. We can answer questions that could never have been answered before. Things like, if you want X rare earth element in Canada, where's the best place to drill a hole? These are now answerable questions. You know, we can use big data and consumption. So where there's things that are foundationally broken, like the way we finance juniors, there's opportunity. And so in this room, I hope there's lots of thought on how do we do this. Decisions, it all comes down to decisions, right? They're all critical, high stakes, and strategic. So investing in exploring, discovering, developing, optimizing, and delivering, right? We must be much, much more informed and more thoughtful. And this room of innovation needs to be 10 times this size, right? This is a key thing for the world that has to be delivered, and we need to grow it as fast as we can. So there's opportunity. And I used to say AI, as a fun aside, we have a term for AI that I like to say I coined, A²I, which is artificial intelligence. So the industry hates the term AI. We have it in our brand, unfortunately. But there's just this guttural response that AI is a fix, and it's just overshot, right? So now I said innovation. And so what we need is more innovation. And that was just what I was excited to talk to you guys about today. And so that was my little short introduction to just say, hey, we've got a supply problem. And if we make better decisions in this industry, there's no reason to have a supply problem, right? And so that's at the heart of what we as an industry can accomplish. So how do we approach the problem at GeologicAI? Well, we recognize that geologic understanding is the point of maximum leverage. So there's a ton of value in being a little bit smarter in geology. If you can actually have a data-driven approach to geology, you can really fine-tune what happens, right? We can find lenses of deleterious elements earlier. We can work with First Nations and say, hey, if you want to have land for future generations, here's early knowledge about geology so that you can make more informed decisions about which land to hold for future generations and which land to keep for development. and we can just be smarter. And so this leads to things, those broad terms of mission, vision, and values. And so we actually believe in what happens if we as an industry and us as a company succeed. There's no more global mineral supply crisis because the world will make better resource decisions, it'll have better mining outcomes, and therefore more critical minerals. And the moment you do that, you have less cost, less time, and less carbon. What are we actually good at? Well, we're that connector of the physical rock to these wonderful ocean of AI, right? There's more work being done in machine learning research in a week than has been done in geostatistics in the last 25 years. So somebody has to build the quality control system that ties this flow of information to rocks at ultra high resolutions. And so we're scanning 1 million meters, 2.7 kilometers-ish a day across all our sites. So that's 1 million meters of core a year. That's about 0.5% of the entire cores cut in the world. And so we are here to elevate everyone to be doing this. Like, let's get going. We need lots of competition in the space. We need people scanning rocks. We need people looking at rocks. We need people connecting it to AI. You're welcome to use our platforms and our systems to help because we know this has to become a big thing. And what are we dedicated to actually do? So as a company, we are hoping to drive home and be the trusted source of geologic truth. And geologic truth is not a map. Geologic truth is recognizing uncertainty and where it exists. And in our case, instead of saying uncertainty, which is a great term, I like to say simulation. So run via simulation. In geoscience, we collect 1/1,000,000th of the data about the rock. And so there's a lot of uncertainty. And we need to have simulated outcomes to do that. And we're really proud that some of these are starting to really work. And so we have to be comprehensive, we have to be sophisticated, but we always have to be practical as well. So we have some values. What are we doing? Well, better resource decisions faster. So we're fortunate to be working with the top 10 mining companies deploying this technology. So let's scan rocks, and then let's reconcile all of the information flows with big compute engines. So some of our projects include, and things that I get really excited about, some of our projects are Australian optimization of short-range planning to optimize iron ore flows through these giant blast furnaces in China. So, from shovels to rail cars to ships, if you mix that a little bit better, we have a paper out on this. It was published with Anglo at Sission. If you just mix that iron ore a little better, you save 5% of CO2 of blast furnace. If we can do that for the whole industry, the amount of CO2 produced and saved by that 5% number, that's 40 million cars off the road. It's one of the biggest and most immediate opportunities for, a carbon solution. Is it because of our tech? No, but it's because of people working toward that 5%. I have another customer in high resolution world working on heap leach piles. And I said, how are you justifying this enormous investment in lab? It's very easy to see. They're running one of the largest labs in the world, doing tons of XRD work. And it's very easy for a business person to say, just cut that in half. We don't need to do every drill stem, do we? We can do half of them. And the answer is, Grant, we're up 20% in production, so we're doubling down from this. And so it's coming, and all these optimizations are working, and we're proud to be part of that. So for us, it's enhanced data, it's purpose-built solutions, analytics, and then tied to people, right? Because ultimately, what work is actually done, what's changing with AI is the experts are becoming much more valuable, and their impact is becoming much greater. And so you have smaller staffs that are smarter. And that's just the future of almost all AI-enabled decisions. And so we started with very narrow wedges, core scanning over here on the data acquisition side, and then, of course, products around that, then how to integrate it, and then resource modeling. So we're dominant in geostatistics. In fact, there's a conference in Australia that 100% of customer papers were using our technology. So we built this library engine thing that people use for resource assessment. And so again, it's a weird way to get started if you have a big vision, because you want to tie it all together. We've got narrow wedge in scanning, narrow wedge in data processing, and it's coming together. So how do we advance it? We have turned our business into three pieces. Resource knowledge systems, that's scanners, that's quality control, that's data flows, that's understanding the rock, tying the rock to AI. Resource modeling solutions, taking all the data of the site and getting everything completely optimized, all the way from scans into plan optimization and high-speed shovel movement changes, right? And so, okay, so we're getting really good at this for the majors. How do we address the juniors? You know, the amount of work to look at a rock for major is the same as a junior, and build AI systems and products. So thousands of juniors, they don't have a ton of rock flow. How do we address that? We've now launched what we call resource exploration strategies. So take the superpower of working in a high resolution world for the majors and advance exploration sites and just do it really, really well. And so, you know, we know this technology stack exists. We want to do something better. We're good at raising money. On our last raise, we said, okay, let's launch. Part of the raise is I want to launch this entity. It's a way to accelerate resource advancement. So we've got some of the great explorers in the world, Murray Hitzman, Patrick Redmond, on staff. We're working on how do we look at properties, and we've picked one. So on Monday, we finally announced a partnership in a heap leach potential project in Arizona. And this is rubber hits road time. This site will be really fun. So we've said, okay, we evaluated what are above ground risks. We looked at a whole bunch of 100 different potential juniors to work with. And we looked at this and said, heap leach, it's already been operating. We can get it to fees in record time. So it was an operating heap leach project. So we're going to just do it. And it's really fun because at the same time as raising money, I was at a conference with our Breakthrough Energy folks, which are really, really fun conference because it was their investor meeting. And one of the heads of the fund, Breakthrough's fund has like Bill Gates and folks in it. So it's really a nerve-wracking moment. But we were working on this deal. And one of the heads of the fund goes to me, Grant, can we just buy a damn mine and do this? I was like, awesome. Because you could just feel that little, because you're working there, you're presenting, you're doing all this investor relations work, and suddenly that's the question. And I was like, oh, so this is a good idea. So I hope it is. You can watch us in the story here. It's going to be fun. There isn't going to be a core shack. That's new. So all this logging will be done off-site. We'll drill, we'll optimize every drill at every point. We're going to vector, we're going to work within the system and bring it to fees as fast as you can. I already have a resource model built and reconciled to what they've published before, and it's live. And so it's a whole new act of disclosure, it's a whole new act of trying to get this mine to work, and we're inviting technology suppliers in. So if we want to prove things up, there's a place to do it. Again, not operating, but that's all I can offer because we're doing the best we can. So that's my little story. If you wanted to see what we actually do, we put trailers out in the field that are robotic platforms. They have a plethora of sensors on them. That's rocket fuel for artificial intelligence. They come with their own processing stack. These are now, our new generation is called a data frame. Doesn't need wheels anymore because they don't leave sites. It's just a frame, and then it has everything you want to put on there, and it's got all the systems for quality control. And so we can get to basic products really quickly, and then we can build advanced AI products, which are things like auto-domaining of lithologies, auto-domaining of rock types as you drill, all sorts of interesting a plethora of tools are being built site by site. Of course, you have to visualize that, so we have software product around that. And then we have RMSP, which is the language of geostatistics. Resource Modeling Solutions Platform is what that stands for. And because it's a language, it's based on thousands of papers that are in company. We actually have chat. So it's a Python language with all the optimized engines. You can talk to it. How do I model copper? How do I do this? And it's great. So this is really growing quickly for us and is kind of foundational to our offering, right? This is the ability to automate existing workflows and then tie them to new AI features. And we launch it into a thing called automated modeling platform. High-speed instant models, real-time updated. This is being deployed at the super majors pretty quickly. So yeah, that's GeoAI. It's just a pleasure to get the chance to talk to the innovators. I'm here to say hello and come see me if you want, and if you have ideas on funding or how to elevate what you're doing, we're keen on that. We came through a wonderful program in investment called Creative Destruction Labs. We're the first company that has gone through Creative Destruction Labs that now funds the mining arm of Creative Destruction Labs. So we're all about giving back and promoting and doing the right thing and living meaningfully. So if you want to chat about any of that, it's a real pleasure. And thank you very much for having me today.
Just real quick, Grant, before you leave the podium, is there any questions from the audience for Grant or Hayden?
Yeah, what's been the biggest challenge to get to where you are so far? It's inspirational, actually. How far you've come?
Get to the mic again.
Sorry.
No problem. So you bang your head against a wall, and either your head breaks or the wall breaks. And there's a bit of gambler's ruin to all of this, right? If you want to do something, you have to. If you're going to go venture, there's no point not going big. And so for us, as people who came from the oil patch and understand very linear businesses, to actually think like a technology company and be like, yeah, it's time for venture capital. It's all about markets and ability to penetrate. It's not about cash flows and how to make money. It's still painful. And so we're working on that. And I think we're finally getting that legitimacy as a tech company as opposed to just, a very linear growth business. And I still have internal struggles with that with everyone all the time.
Anyone else? Yeah.
Thanks for this presentation. You talked about the importance of simulations and embracing uncertainty. And everyone who's done modeling and planning appreciates how uncertain it could be and how risky. I wanted to get your thoughts on what are the biggest barriers on adopting simulations and what has been your approach to overcome that?
Well, if you talk to Clayton Deutsch, who's, father of geostatistics, or one of them, wrote the original GeoSlide. Simulation, he did a presentation that, it's been 25 years of us saying it's time for simulation. And it's difficult. So we have finally got it working. And so now that it works, I think it will infect quickly. But the biggest flagship we have publicly is of significance is Lundin BHP's discovery of Vicuña. That's the first resource that's been published and its only simulation. So yes, it's reconciled to traditional ways of doing resource estimation, but it's actually 100%. Here's a simulated estimate. And because that's now a technical flagship, the rest of industry can start doing that. And so, we have to do it through example. And again, when you talk about resource estimation and all the narrow pieces of that, that's really difficult. But I think once you can get past that, well, we should be able to do it in other operations. And so like our simulations of iron ore flows, that's working, right? The plants are running better. And so once you have that starting to actually work, as opposed to promises of actually working, I think it will just, it doesn't become a question of we should think about simulation. It becomes why aren't we doing this now? Because it clearly makes more money. And I think that's where it's just early signs of the adoption curve is coming.